Let's look at this problem from your review sheet. This linear equation in one variable has fractions. This is problem number 8. Remember, when we have linear equations, actually when we have any equation with fractions, the typical approach is to remove those fractions by multiplying through by a multiplier that will cancel the denominators. And in this case, that multiplier we want to use would be the least common denominator for the denominators, which in this case is 12. So I'm going to take 12 and multiply it times both sides of the equation. So that means I have to distribute the multiplication of 12 times both of those terms. Now remember, before we multiply times fractions, we want to reduce. And remember, the whole number is like having that number over 1 if you want to treat it as a fraction, so that we can then do our canceling before we multiply what's left. Well, 4 goes into 12 3 times, so now I have the 3 that needs to be multiplied times both of those terms. We can do that in one step, I think, can't we? Take the 3 and multiply it times both of those terms. 3 times 5x will give us 15x. And 3 times the minus 3 would be minus 9. These are whole numbers, so 12 times 2 is 24. Equals, let's do the canceling here that's possible. 3 goes into 12 4 times, so 4 times x is 4x. Now we can continue with our solution to this equation. I see that I've gotten rid of the parentheses that were there, and now I can combine the like terms that are here. (15x minus 33 equals 4x). Now, I only want one term in my equation that has the variable. So I either want to get rid of the 15x or get rid of the 4x. If I get rid of the 15x, that will isolate the x's over here for me as well, won't it? So let's do that. Let's get rid of the 15x by subtracting 15x from both sides. That leaves me negative 33 on the left-hand side of the equation. And 4x minus 15x, you have $4, you owe 15. That would be the same as owing 11, wouldn't it? And now we have that x term isolated, which is our next step that we want to attain, which we now already have because of the choice we made back here to make the 15x disappear. And now we can make the coefficient positive 1. Remember, it's the same coefficient is what you have to divide by. The number over itself equals positive 1. And we'll divide the other side of the equation by negative 11. So x equals negative 33 divided by negative 11. That's going to give us negative divided by negative is positive. 33 divided by 11 is 3. So the solution to this equation is 3. So if we were to take 3 and plug it in place of x, and then simplify the expressions, the left-hand expression would have the same value as the right-hand expression. Let's check that real quick to see if that's true. If we put 3 in for x, this right-hand expression is going to become 1, isn't it? If I put in 3 in for x, 3 over 3 will be 1. Let's put 3 in here. 3 times 5 is 15. 15 minus 3 is 12. 12 divided by 4 is 3. And 3 minus 2 is also 1. So indeed, that value of x makes the left-hand expression's value the same as the right-hand expression's value. That's what it means to have found the solution to an equation.